Good evening students, welcome to basic electrical lectures. So in this lecture we are going to solve problems on DC motor, that is part 2 lectures. In part 1 lectures I covered problems on types of DC motors, that is shunt motor, series and compound, long shunt and short shunt. Like that I covered some problems. Okay, other way of asking other topics on problems on DC motor is they will ask problems on torque and speed relations. Okay, see these problems mainly based on how you know the concept. Okay, if you are good in concept, then only you can solve problems on motors of torque and speed relations topic. Okay, so got it. So in that whenever you are solving problems on shunt motor, we should be very careful for the following pattern of questions. Okay, so what is the pattern of questions that we can discuss now? Okay, look at here. Once I completed everything, you pause the video and then copy down this concept. Okay, what concept I am explaining now, that is applicable only for shunt motor. Okay, because we should be very careful while solving problems on shunt motor, specifically torque and speed relation topic. Okay, got it. For series motor, you need not to worry. Simply close your eyes, whatever the data given in the question, just substitute in the torque and speed relation. Okay, then press equals in the calculator, you will get answer. Direct question. Okay, so we can discuss shunt motor. Okay, suppose if, so red is not working, so every time red is giving trouble for me, so no problem. See, if the question is in this pattern, so flux, this is called flux. If the flux decreases, I am not writing entire word, if the flux decreases or increases by some x%, and torque is constant, this is the condition in the question they given. Okay, torque is constant, they will ask, then calculate new current or new armature current and new speed. Okay, wasa speed. Okay, what will be the new speed? So this is the question. See, whenever they asked this type of question, the solution will be, this is the solution. Consider flux parameter. Consider flux parameter, flux FLUX parameter in both torque and speed relation. This is torque and this is speed relations. So what is torque relation? Okay, right, this is not working. So torque relation. Torque is proportional to what? Pi Ia. And what is the speed relation? N is proportional to what? Eb by pi. Okay. So you have to consider this flux in both torque and speed relation for this type of question to calculate new armature current and new speed. Got it? So how to do that? See, all this type of problems will have two cases. Okay, first case, some flux, this is the machine running, this is the speed machine runs. If I change the flux, what will be the new speed? Like that, there will be two cases. So in the first case, the torque will be T1. In the second case, the torque, some other torque, new torque, okay, is equal to, you take the flux also, pi 1 by pi 2. This is flux in first case. Later flux changes, maybe increase or decrease. And this is the armature current, Ia1 by Ia2. Armature current in first case divided by armature current in second case. See, sometimes this pi 1, we can also write shunt field current. Okay, because we are discussing shunt motor. Okay, whatever the concept I am explaining, applicable only for shunt motor. Series motor, no concepts. Directly you can do it. Okay, so pi 1 is proportional to ISH1. Like that, based on this, if the flux is proportional to field current, okay, then we can write other way, T1 by T2 is equal to, so flux I am writing shunt field current, ISH1 by ISH2 into IA1 by IA2. They will give all other data. From this relation, you are going to get, you are going to find new armature current. So you should, by using this relation, you have to find new armature current. Then how to find the new speed? So two cases are there. So in the first case, there will be some speed N1, and in the second case, there will be speed N2. Okay. So EB, numerator, EB1 divided by EB2 all divided by pi 1 by pi 2. So further what happens if I simplify that? So by simplifying that, we can write N1 by N2 is equal to EB1 by EB2 multiplied by, if I take this top side, then it becomes, so pi 2 by pi 1. So using this relation, you can find new speed. N1 is old speed and N2 is new speed when something changes happen. Maybe torque constant or flux increase or decrease. Okay, got it? So using this two relations, okay, this one and this one, you can find new current and new speed. This is one case. Okay. Next, other case is, okay, now pause the video, copy down this entire part. Okay. So later, next case is, so they are going to increase, flux increase or decrease by some x%, and also torque also increases. Okay. So let me write this. Okay. So torque also increase. So torque increases or torque decrease. Anything can happen. Vice versa. Okay. If the torque increase or decrease by some x%, by some x% or y% or z%. Okay. So torque increasing by some x% or decrease by some x%, and flux also increase or decrease by some x%. This is the pattern of question. Okay. And they will ask, then find new armature current, and new speed. Then find new armature current and new speed. Okay. What will be the solution for this? See, when both are varying, flux also varies, torque also varies. Under that condition, you consider flux parameter only for torque relation. Okay. If the given torque is constant, then you consider flux in both the torque and speed relation. Got it? So very, very important. Solution is consider flux parameter only for which one? Very good. Torque relation. Consider flux parameter only for torque relation. What about speed relation? Don't consider flux in speed relation. Got it? So guys, pause it and then copy down this entire part. This will be the second part. Okay. I am going to write relations now. Pause the video and then copy down. Okay, now I am writing solutions for this. Okay. What is the solution? When both varies, flux you should consider only for torque relation. So what is the torque relation? Torque is proportional to pi Ia. Write two cases. T1 by T2 is equal to pi 1 by pi 2 into Ia1 by Ia2. So using this data, you can find new armature current. Then what about speed relation? N is proportional to EB by pi. Speed relation will not change. This is a relation. But you should not consider flux parameter in speed relation for such type of questions. Okay. So therefore, then your speed relation will become what? N is proportional to EB. So therefore, two cases, N1 by N2 is equal to EB1 by EB2. So by using this, you can find new speed. Okay, got it, guys? Very, very important. Okay, note down these 2 points. Okay, so to solve problems, these 2 plays very important role. Okay, got it? So they will ask same pattern of question, either first concept or second concept. Okay, so based on that, they can make different changes in the data. Okay, later very easy to solve the problem. Now let me read the question and you should say whether the question related to case 1 or case 2. Okay, got it? Okay, a 440 volt DC, whatever it may be, don't worry. 440 volt DC shunt motor takes some armature current of 20 ampere and runs at 500 rpm. This is first case. The armature resistance is 0.6 ohm. They given if the flux is reduced by how much percent? 30% flux is reduced and torque increased by 40%. Calculate new value of armature current and speed, new speed. Okay, got it? So this question asks for 7 marks. It is repeated 3 times for whole scheme, 17 scheme. But the same topic is also included in 18 scheme. Till now they didn't ask. They can ask. Okay, day after tomorrow or after next time. Next semester, next coming batch. Okay, now I will give to you whether this question related to case 2 or case 1. Observe. Yes, obviously, because obviously it is second case. Okay, flux is also varying, torque also varying. So both are varying. So what is the solution for that? We should consider flux parameter only for torque relation. Okay, got it? So pause the video and then copy down the question. Okay, students, now we can solve this problem. So it is related to second concept because both they are changing. Flux also changing, torque also changing. So let's start. A 440 volt DC shunt motor. It is taking an armature current of 20 ampere. So that's why I am writing here. A 440 volt DC shunt motor taking an armature current of how much? 20 ampere. And it going to run at 500 rpm. So under this condition, you can consider there is some amount of flux and there is some amount of torque. So this is the initial case. Okay, case 1. You should consider this flux is 100% and this torque is 100%. Okay. So with respect to this is the initial condition. Later, what they are doing means the armature resistance is 0.6. Okay, resistance value is 0.6. Now the conditions start. The flux reduced by 30%. See, this is 100%. Pi 1 is 100%. Later, for the same motor, they are going to decrease the flux by how much? 30%. So what is this? Actually 100%. If I reduce 30%, what is remaining? So the new flux will be 70% of original flux. This is original flux. Okay, 30% reduced. So therefore, the new flux will be 70% of original flux. Got it? Next, the torque increased by 40%. See, this is 100% torque. Now this, in the second case, they are going to increase or decrease some torque. But in question they are given increase by 40%. So what will be the new torque? With respect to this is 100%. Increase by 40% means 140. Okay. So 140 can be represented as 1.4 times of T1. See guys, 100% is nothing but 1 only. What is percent? 100 by 100. 100 by 100 is how much? 1. Okay. 140% becomes what happened? 140 by 100. It becomes 1.4. So very basics. So got it? Suppose if the given torque decreased by 40% means, so this is 100%, reduce 40%. What is left? 60%. So the new torque will be 60% of previous torque. Okay, got it? So at this flux and this torque, the machine is running at this speed and receiving 20 ampere current. Now they are going to change some parameters. Torque they increased and flux they decreased. What will be this current and what will be the speed? I hope you understood the question now. Okay. So let first find the armature current. So we need to consider flux parameter only for torque relation. Okay. So what is the torque relation? Torque is proportional to pi Ia. Two cases are there. T1 by T2 is equal to pi 1 by pi 2 into Ia1 by Ia2. So T1 is what? T1 is nothing but it is having some torque. Okay. Pi 1 is having some amount of flux like that. Okay. So T1 is having torque T only and T2. So let me write T1 only. Let me write T1 only. And what is the new torque? New torque is what? 1.4 times of original torque. 1.4 times of T1. What is the flux pi 1? Let's write pi 1 only. And what is pi 2? What is the new flux? Reduced by 30% means what is left that you write? That is 70% of original flux. Don't write 0.3 times of pi 1. That is wrong. Okay. So 0.7 times of pi 1. And what is the current in the first case? 20 ampere. So divided by, I don't know this current. Ia2, I don't know. Okay. So now, take the calculator. So this T1 get cancelled. Pi 1 get cancelled. So now you can easily find this new armature current. So by solving in calculator, we will get the new armature current. Let me do here. Okay. In this calculator or some other black calculator. So 1 divided by 1.4 is equal to, so 1 by 0.7 into 20 by Ia2. So I am getting 40 ampere of current. I hope you also got the same value of current. So the new armature current is how much? 40 amperes. New armature current is 40 amperes. 50% completed. But I want to find new speed. Now you take the speed relation. Now take the speed relation. What is speed relation? N is proportional to what? EB only. EB by pi. But don't take flux in speed relation. Okay. Because it is second case problem. Okay. So now take the two speeds. N1 by N2 is equal to EB1 by EB2. Okay. So first you calculate back EMF for first case and then back EMF for second case. So back EMF part I will do it here. Okay. EB1. Okay. EB1. You must know the voltage relation of shunt motor. What is shunt motor voltage relation? V is equal to EB plus IRA. From that I want to write EB1. Okay. So V minus IA1 into RA. What is V? 440 minus what is armature current in the first case? 20 ampere multiplied by armature resistance is 0.6. So how much you get? So 440, okay, minus 20 into 0.6. So yes, I am getting what you got. So that is 428 volts. EB back EMF in the first case. Okay. Similarly, I will do back EB2 value somewhere here. Okay. EB2 is equal to V minus IA2 into RA. Now you should take new current. You already calculated the new current. How much? 40. So now 440 minus 40 into 0.6. Okay. So I think you may get 426 volts. Okay. Yes. 416 volts. 440 minus 40 into 6 is 416 volt. See, after getting those EB1 and EB2 value, now you can enter in the speed relation. What is speed in the first case? 500 RPM. What is speed in second case? That only I need to find. So next, what is EB1? EB1, 428 volts. Okay, divided by what is EB2? 416 volt. See, solve this, only one unknown parameter. solving this, you will get the new speed how much. So let me do along with me. So we both get same answer. Okay. Otherwise, put in the comment box if you get a different answer. So guys, please give like. This problem is very important. That's why give like. So 500 divided by some unknown parameter multiplied by 428 divided by 428. Now I'm writing 4.28. I don't know why I'm doing like this. And 460. By solving this, so I'm getting. I got some answer. What you got? 485. Yes, your answer is correct. Yes, 485.98. What is the unit of speed? RPM. RPM. Rotations per minute. This question asked for 7 marks. Okay. See, same question they can ask it. See, the flux reduced by 30%. Like that. And torque is constant. Means what? First concept. Take flux parameter, both torque and speed relation. Torque relation as it is. In speed relation, you should take n is proportional to EB by pi. Then write pi 1 by pi 2, then do it, you will get a new speed. That's it. They can give, say, flux reduced. They can give this time increased. Other side, torque increased, now they can give decreased. What students will do? This question asked in previous exam, they will read up and by heart at the answers as it is, they will write. But they will do, where increase there, VTU will do decrease. Where decrease, they will do increase. Such small changes, they will do it. Okay. Very few students will notice that and they will do correctly. Majority of the students will write previous year solution only. Okay. So, please read the question carefully. Okay. Got it? So guys, I'm going to stop with this problem itself because I explained the concept. I hope you can do other problems. Okay. So in the next video, I will be doing problem on series motor. Series motor, no concept at all. Directly you will get solutions. Okay, got it? So guys, please give like, share my lectures to all your friends of P-Cycle, your college and also other college students, overall you know. Tell your friends of friends also to share the contents. So let them get benefited. So those who are studying now P-Cycle, for them entire 5 modules will be readily available before taking the examination. So currently exam is there day after tomorrow on 30th July. For them, so I tried my best to do the content on this subject. So in available my free time. So due to lot of disturbance, personal disturbance, so video uploading get delayed. Okay, sorry for that. Okay, dear students, please give a like to our videos if you are satisfied or you are happy. Please give like and type some comments if you get any other new type of questions in your mind. So what will be the solution if they ask such questions like that? You can put a comment. So if it is answerable, I will give a solution for that. Okay. So and then I want to tell our channel has crossed 1000 subscribers. So like this only, keep supporting me. So I will be doing lectures in English. My English is just similar what general, all will talk like that only. So it's not the London English. So in the coming year or the next 1 or 2 years, if any scheme is changed or basic electrical, at that time I will be do the entire subject in Kannada. Okay, my mother tongue is Kannada, but I done entire videos lectures in English. Okay, so my English is not London English. It is just similar to what you are talking. Okay, I hope everyone can understand my English. Okay. Okay guys, keep supporting me. Meet you on next lecture on series motor topic. Shunt motor, we should be very careful. Okay. Bye bye. Take care.